Hello everyone. So welcome to the last session of single phase AC system. The last set of 5 questions. What is the bandwidth? Question number 196. What is the bandwidth of a series RLC circuit having the resistance, inductance and capacitance values 80 ohms, 2 millihenry and 0.01 millifarad respectively? So bandwidth of a series RLC resonance circuit. Bandwidth of series RLC circuit is R by L. Okay, remember it is R by L. So R value given is 80 ohms divided by 2 milli is the bandwidth, and we need the answer in kilohertz. So M, when taken to the numerator side, it becomes K. So 80 by 2K. So 40 kilohertz is the answer. 40 is your answer. Next question number 197. What is the peak to peak value? What is the peak to peak value of a sinusoidal voltage having the average value of 100 volt? So we know that average value of a sinusoidal voltage is 2 Vm by pi, and the average value given is 100. We have to get the peak to peak value. Peak to peak value means this much to this much, this value. This is Vm. So peak to peak value is 2 Vm. Okay, so we have to get 2 Vm value. 2 Vm is 100 into pi, that is 3.14. That is 314 is your answer. Question number 198. Calculate the phase angle between the voltage and the current phasor of a series RL circuit having the resistance 65 ohms and inductive reactance 37.53 ohms and supplied by a frequency of 60 Hz. So again, similar question have been discussed in the last set of 5 questions in the last video. I'll tell you once again, we have to get the phase angle between the voltage and current. The phase angle between voltage and current is the angle phi, which is in between the R and Z of an impedance triangle, and here comes your XL value. So again here R value given is 65 ohms and your XL value is 37.53 ohms. So what could be the angle over here? Here actually if this is phi, what is tan phi? Tan phi is opposite side by adjacent side. Instead of getting the Z value by Pythagoras theorem and all, let's check if we get the same angle phi using XL and R. That means we have to take the opposite side and the adjacent side, which means tan. Tan phi is equal to 37.53 divided by 65. What will be the value here coming up? If it is 32.5 by 65, then we can easily get it around as 1 by 2, that is half, but it is 37.53, so it is coming a little bit greater than 1 by 2, isn't it? So if I write this 1 by 2 as 1 by root 4, and this here the value is something greater than 1 by root 4, which means I have to increase the numerator or decrease the denominator in order to have a value greater than 1 by root 4. So what if I decrease the denominator, that is 1 by root 3. Okay, because I have I have an easy numerical like tan phi, if it is 1 by root 3, then phi is going to be 30 degree. Okay, so the answer here is angle 30 degree. You can also recheck this by doing this in your calculator. Okay, now moving on to the next question. Question number 199. Calculate the value of resonant frequency in kilohertz of a tank circuit having the capacitance and the inductance. So here 1 by 2 pi root of LC is the resonant frequency for a series, if we deal with a series resonance circuit. So it is 1 by 2 pi into root of L and C. L is 0.01 millihenry and C is also 0.01 millihenry. So 0.01 milli into 0.01 milli, and we need the resonance frequency in kilohertz. So 1 by 2 pi into 1 set comes out, that is 0.01 milli, and milli when goes it upside, it becomes k. So 2 pi into 0.01. So it is 1 by 2 pi. 1 by pi I have said you it is 0.318. So 1 by 2 pi means 1 by 2 pi means 0.318 divided by 2, isn't it? So it is 0.159. Okay, so 0.159 k divided by 0.01. So 0.159, and when this 0.01 is taken to upside, it becomes into 100 and k is there. So it becomes 15.9 kilohertz. 15.91 kilohertz is your answer. Move on to the last question. The inductive reactance of a circuit is 60 ohms when it is applied with a 50 hertz supply. What will be the value of inductive reactance in the circuit if it's applied with 60 hertz? It is easy when you know the equation XL. Inductive reactance is 2 pi Fl. So inductive reactance when it is 60 ohm when it is applied with 50 hertz. So 2 pi into 50 L. And what is the inductive reactance when it is applied with 60 hertz? 2 pi into 60 L. When I divide this question mark divided by 60 is equal to 2 pi 60 L divided by 2 pi 50 L. Anyway, it is 60 into 60 divided by 50. So it is 360 divided by 5, or it is, when I multiply both sides by 2, it becomes 720 by 10, which is 72. Okay, so 72 ohms is the answer. So we'll be back again with a new topic, objective type questions from a new topic. Okay, thank you.